So Mayank, link is correct, na? Everything is correct, right? आवाज नहीं आ रहा।
हाँ, एवरीथिंग इज करेक्ट करेक्ट, इशू नहीं है। मेरा वेबएक्स बीच में क्रैश हो गया था, बट हाँ ठीक है, वो होता रहता है ऐसा आजकल इसका।
अच्छा अच्छा, तो ये मैंने लिंक हम लोग मूडल प्लेटफॉर्म पे भी डाल देता हूँ। अभी कोई लेट ज्वाइन हुआ तो चैट बॉक्स में तो बार बार डालना पड़ता है। सेम लिंक में उधर पुट अप कर दिया, उधर से ले सकते हैं। एक बार वापस यहाँ पे नीचे डाल देते हैं ताकि वो लोग उसके बाद ज्वाइन उनको पता चल जाए।
कोड ओपन होता है क्या सर? बिकॉज इन माय लैपटॉप इट इज नॉट ओपनिंग।
सो आप लोग बाकी लोग रिस्पॉन्ड करो ना। हाँ, मेरे इसमें ओपन तो हुआ है लिंक्स।
नहीं, कोलैब में जाके वो पूछेगा कि डू यू वांट टू ऑथराइज। नहीं होना तो चाहिए।
ओपन नहीं हो रहा है सर।
सर ओपन हो गया, कोलैब में हो रहा है।
हाँ, तो वो कोलैब में पूछता है ऑथराइज विद गिटहब, तो ऑथराइज कर दीजिए अपने जीमेल आईडी से। अच्छा, मैं देखता हूँ कि इफ आई कैन सेंड द डाउनलोड लिंक डायरेक्टली आल्सो। GitHub lab learning. Let's see, Windows V. It's downloading, not opening, not opening. Okay. So it's okay. चलो मैं इसको एक बार देख ही लेता हूँ वापस। मेरे यहाँ तो खुल रहा है। I tried it from a different Gmail account also. Copy, drive and just copy, save as a copy.
मैं एक काम करते हैं, हम चालू कर देते हैं ना ऑफिशियली अपन।
हाँ, चलेगा चलेगा।
गो इन डिस्कशन। या दैट इज गुड। या पल्लवी मैडम।
Yes sir, yes sir. Good. Am I audible sir?
Yes, perfectly.
Yes, go ahead.
Yeah. Yes, very good morning to all of you. I Pallavi Thakur welcome one and all here on behalf of organizing committee at Bharatiya Vidya Bhavan's Sardar Patel Institute of Technology. I take this privilege to warmly welcome you all on this fourth day of AICTE sponsored 2-week online faculty development program on Insight to Intelligent Automation, Machine Learning and Data Science, and under this third FDP, Data Science and its Applications. I find immense pleasure to welcome Dr. Mayank Agarwal. Dr. Mayank Agarwal is an assistant professor in IIT Patna. He has done PhD from IIT Guwahati and postdoctoral researcher Ben Gurion University of Negev, Israel. And we are very proud to say that he is our alumni from IT department 2009 batch. His research area includes 802.11 wireless networks, modeling. He has published many papers in various international and national journals of repute in the domain. He has awarded TCS Research Scholar Fellowship in 2011, which is awarded to only 40 research scholars annually across India. I welcome you, sir, once again. And now I request, sir, to please take over the session.
Yeah, thank you, Pallavi ma'am, for the kind introduction. So, all of you, I think the collab link should work, right? So let me first share my screen and just show you how it should look like. Okay, so okay, Sony ji will have to, I think, stop sharing screen. Okay, you are sharing Microsoft Edge. I think the screen is visible, right? The Edge screen. What is
Yes, yes,
collaboratory and all? Yes,
yes,
yes, yes,
visible.
yes. So we can just do an open notebook, come to GitHub, and you can just paste the chat link. Probably it may ask you to authorize GitHub. So if you don't have a GitHub account, I think that will be the one. Okay. Sorry for this interruption. Just let me pause. Okay, so this is how it will look. So github.com, this link is there in the chat window. And this is how the repository will appear. So in case it is not opening, just copy the URL, go to GitHub, and then you can download the code from in the zip format from here. Right? So you just download zip. So this contains all the files that you require. Just extract it on the desktop. Once you extract it for lab learning, you can just import these files into Colab, right? I think I'm just sharing my, sorry. People are viewing two applications. Okay, fine. So in my case, I will just close the screen and okay, so I just start with T1 Pandas. Actually, I'm giving some time to Pandas before because there may be users who are not aware with Pandas. So if you are getting this tutorial, just see the T1. So I ordered my all Python notebooks in T1, T2, T3, T4, right? So let me click on this arrow. So you can just see this particular arrow on the right hand side. So it will take some time to open. Okay, so now we have this Pandas data tutorial, a complete introduction for beginners. I think many of you may be knowing Pandas, but there may be some people who are not aware of Pandas as of now. So I think it's a good refresher also for those who know Pandas and a good tutorial for those who do not know Pandas. So with Colab, basically you get a complete execution platform. So you just write your code and see the real-time execution. So we will look through at Colab also. So just see the window on the left pane. So you have this drawer, a lens button, and this folder, right? So just click on this folder. It will take some time to browse for the file, right? So it is saying connecting to a runtime to enable file browsing, right? Also, there is a connecting button here, right? So basically, Google Colab initializes RAM and hard disk for you. So see now you can see RAM and hard disk. So you can see you have 0.75 GB out of 12 GB RAM and disk is 31 of 107 GB. And then you have some sample data. Okay. In the first button that you can see here is upload to session storage. right? So even if you open via GitHub Notebook directly or by browse, you need to upload the CSV files. Okay, so let me just upload the CSV file that I require. Actually, I can upload the whole folder except the notebooks. So let me upload all the files. So you have the asset folder, dataset, database.db, and we have some JSON and CSV file. Just click on open. So it says a warning reminder uploaded file will get deleted when this runtime is recycled. So it means that when you close this session, these all will be deleted. So we are okay with it, no worries. Right. So now you can see on the left hand side, we have the CSV files, the JSON files and everything that we required is on the left pane. Okay. So why pandas, why machine learning and why time series? Right. So mostly when you deal these days with data analytics or machine learning or AI or deep learning, whatever umbrella that you keep it on, right, it requires a huge amount of data processing. Okay? Like in India, we say data is the new oil, right? So something of that sort is so applicable here also. So why pandas became so famous? First of all, Python was very much preferred by guys who are also from non-computer science background because the ease at which it offers, it feels like you're talking in English in a programming language. And then Python has a huge community support. And of course, Python, the guy who developed Python was hired directly by Google a few years ago. Right, so it can just show a small graph, the rise in popularity of pandas. So 1% of the Stack Overflow question actually became from pandas, right? So why was then pandas used for, right? So basically, probably a few of them only know, pandas annual data, right? An economics term, but this is where it gets a derivation. And pandas is used for doing all kind of data analytics. It is used for plotting and all other things, right? So without having much ado, let us directly go into some hands-on, right? So first step is to install the pandas library itself. See now, Google Colab is an environment for executing your Python and all the data science stuff, but it does not have all the libraries by default. It provides you the basic code. Okay. So now you can see in this notebook, there is a code window. How can you insert a code window? So you can come into the insert cell, right? And there is an option code cell. So when I insert this code cell, you can see there is a code cell which has been executed here. So for this, I would say you can remember a shortcut. So for example, if I am on this particular screen, right, pip install pandas, I can press control. Okay, I can press. Okay, I cannot because control M is conflicting with this. Okay, so I am having an insert cell. So when you insert cell, you can write something, any code which you like. So let's say hello world, and then you can click this play button. So you can see there is a shortcut here, control enter, right? So when you play this button, it will say for the very first time, a warning is there. It is not authored by Google. It just say run anyway. Basically, it just gives you a warning saying that, okay, this may be a third party notebook which may contain malicious content. So just say okay. Right. So you see when you execute print hello world, you can get this hello world as the output, right? And you can do any kind of calculations also here. 1 + 1 press control enter. It will say 2. Okay. So any kind of Python function can be implemented here. So the first step is to install pandas itself. Okay, so you just write the command pip install pandas. Ensure that you have a semicolon, you have an exclamation mark here, so that the process go inline. So you can click the play button using your mouse, or you can just say control enter. So it says requirement already satisfied. This. Okay. So well, first step is successful. Okay, that it says the exclamation at the beginning runs cells as if they were in a terminal. So usually these commands will run in the Windows terminal or in Unix prompt. So in case you are executing there, please avoid the exclamation button. It will give an error. Exclamation is only to be used when you are installing in Jupyter Notebook. Okay. So now this goes. So now we are importing pandas as PD, right? So if you remember in C, you used to import include stdio.h, include conio.h, mat.h. Similarly in Python, instead of include, we have import. Python also provides you a major feature by having aliases for the libraries. What do I mean by aliases? Aliases means, for example, if I want to import any function from pandas, I have to write pandas.import or pandas.sort, pandas.drop NA. So what I'm doing, I'm giving a pet name to pandas library. Just like in Indian homes, we have a pet name at home, right? So everybody is Chotu, Motu, Golu, something like that. So whenever I want to refer pandas library, I can use PD as a shorthand for it. So every cell must be executed. So I'm pressing Control Enter. So no errors, no warning, right? So for example, if I give a wrong name to a library, the Google Colab will throw an error. For example, I will give a library called pandas 777, which does not exist actually. So when I press Control Enter, see, module not found, right? So by default, the Jupyter notebooks are trained to be very silent in their operation. So no output means everything is fine, right? No acknowledgement here. So now core components of pandas. So it has two main components, series and data frames. Technically they are one only, but just a very minor difference. So series is a single column, right? Now, how do you remember that? So I just wrote a small thing here. Series begins with S and single also begins with S. So you can remember this analogy. Series means a single column. Series again, like for example, apple here is a single column, right? Again, there is a series oranges, which is again a single column. This 0, 1, 2, 3, I will explain in a while to you, right? Don't worry. And when you combine columns, it becomes a data frame, right? So data frame is a multi-dimensional table made up of series of collections. So even if you have two columns or more than two columns, it's a data frame. So if you have only two columns, right? This data frame has only two columns, apples and oranges. So it becomes a data frame, no longer a series. Why? Because it has two columns now. So this 0, 1, 2, 3 is not a column, although it appears a column. It's an index into this. So this basically is the zeroth row, first row, second row, third row. It is an indexing auto assigned by pandas. Now, what does indexing mean? So just like, for example, when you run a for loop for I equal to 0, I less than 10, I plus plus, right? So I had as such no implementation with regards to the logic. It was just helping for looping the loop, right? Similarly, pandas feels that, okay, whatever rows you have, I need to uniquely identify each row, right? So for example, if this row had two zeros, for example, 0, 2, 0, 1. Now, how do you identify whether you are referring to the zero of the first row or the zero of the third row? So in this case, this index works. This index is unique. So if you have 10,000 rows, it will begin from 0 and go up to 999. Now creating a data frame from scratch. Now how do you create a data frame? Multiple methods are there. So we will look at the easiest thing. So this same series, right? So we will make a series out of it and then combine it into a data frame. So let us see how do we do it. So if you see this data, let me, I think zoom it will appear better. This is too much of a zoom. Let me close this one. Okay, this should be, I think, a good font size. Rathod sir, ये दिख रहा है better?
Yes.
Clear है? Yes.
Yeah, that is clear. Although the screen is also on your side. Okay, so now data, if you see, basically this is a dictionary. So in Python, just see my integer floats and everything are there. Python also has a concept of dictionary. Now, why it is called dictionary? Because it has two things. If you can see, there is a colon here. So on the left side of the colon is like a separator here. So the left side of the colon is what is known as a key. And on the right hand side, you have a value. So when you see any dictionary, Hindi to English, English to Marathi or anything, so on the left hand side, there is a word. Like for example, the word is, let's say, college, right? And on the right hand side, you have a meaning, an institution where the students study their higher degrees and everything. So what is the property of an English or any dictionary that you see? That the words on the left hand side never repeat, right? Because all the words are unique. You cannot have two entry for colleges in a dictionary, right? That is faulty. So every left hand side word is a unique thing. The same applies in Python also. Whenever you have anything on the left to the colon, this has to be a unique thing. And on the right hand side, you can have anything. So this, for this particular key, this can have any value. So I can even repeat the right hand side. Just like, for example, there are so many common words which have the same meaning in English, right? So their meaning may be same, but the word itself will be different, right? So let me keep the original thing right now, and then you can just check for the type of the data, right? So let me erase this and press Control Enter, right? So it says the type of the data is dictionary, so it says DICT, right? So let me insert a cell below, code cell, and just let me get the contents of this dictionary. So I'm writing, oh sorry, not dictionary, data. Data is here. And so you can see apples colon this separated by a comma, again oranges in this. If you just want to check that what error does it pop up, for example, I keep the left hand side same, right? Now I have two keys which are of course invalid, just like in a dictionary you cannot have. So now it will pop up an error. Okay, type, let me just check, should have popped up. See, it gives you only one entry, right? 0372. So basically it ignored this particular entry and only kept this particular entry, right? Because the keys have to be unique. If I'm repeating one more time, let me just keep one more time. This is, let us keep 9, 8, 7, 6. Let me execute. And now my data will be 9876, right? So as you can see, if you have duplicate keys, the last one will be the value that is being taken, right? So frankly, avoid this, never use these kind of stuff, right? Because you may expect an unexpected output, right? So we have our apple and oranges ready. Now again, if you see, this is a data type dictionary, right? So if I say data comma type of data is, right, again it is saying dictionary, right? But what are we dealing with? We are dealing with data frame. So how do I convert the dictionary to a data frame? So simple command is there. See, I have used here PD, right? So when you hover over PD, it says it's pandas. Why PD work? Because in the first step we inserted pandas as PD, right? If I inserted pandas as PD1, then successively I have to use PD1 here, right? So PD is dot data frame. Data frame again is an inbuilt function, and you can see it's a function because you have round parentheses here, and I am passing data. What my data had? Data had oranges and apple, and I'm storing it as purchases. So when I view this purchases, you can see I have apple and oranges. Apple was 3201, 3201, 0372, 0372. Again, if you see, pandas automatically adds this index 0123. Neither in apple nor in oranges I had 0123. So this is just to refer a unique row. The first row is this, second row is this, the third entry is this, right? So how did this work? We just saw this. And for example, in this index, this was 0, 1, 2, 3. I can have any index that I want. If I want this index to be 10, 11, 12, 13, I can have it. And I can even have text-based indexes also. So we will just see in the next stream. So for example, purchases, right? Why purchases? Because I made this data into a data frame which is known purchases. So purchases is again pv.data frame. I am again passing data, but I am explicitly specifying index here. So if you see in my previous command, I did not specify anything. I just passed on data. Now I'm specifying index. So I love to see cricket. So Sachin, Saurabh, Dravid, and Lakshman. Right, so now you just see the output here. Sachin, Saurav, Dravid, and Lakshman. Mind it, it is in the same order that you specify here. Sachin, Saurav, Dravid, and Lakshman. You can have even anything. For example, let me just copy this line and have it. And it need not be in any order. 55, 99, and 2. Right? So let me try to execute, hope it works well. See, 88, 55, 99 and 2. So you can define your own indexes if you wish, or let Python choose its own default index, right? So while I'm coding, you can interrupt me in between if you have any doubts, but please try to play around with it. When you see pandas, it appears to be very easy, but when you actually type it out, you get many kinds of errors and those things. So now how do I locate a particular entry in this? Okay, so let me just re-execute this. So I have our Sachin, Saurav, Dravid, and so how do I locate a customer order by using their name? Okay, so for example, if I want to locate, okay, what did Sachin buy or how many apples and oranges did it buy? So there is a function called location. So if you see from the English word locate, it picked up the first three characters. So from the location, I'm saying, okay, I need the entry for Sachin, right? So in location, basically you are specifying an index. So if you see our index here is these particular names. For example, if our indexes was this, I would have just used purchases and in the bracket I would have written 0 or 1, whatever I required. So for example, here I want to see what purchases Sachin had done. So you can see apples were 3 and oranges are 0. Name is Sachin and data type. D type basically means data type. It's a 64-bit integer. On 32-bit systems, it will come as int 32. So no need to worry. Right. Similarly, let's say we want for Dravid. So I just replace this particular value by Dravid and I see apples as 0 and oranges as 7. Right. To what I remember, I think we can pass multiple lists here. For example, if I see Dravid and Lakshman. Okay, that's an error. So you cannot pass two keys. Oh, I think the issue is here with the bracket. Should come out actually. Yeah. So you can specify multiple keys also if you want to specify, right? So eventually the LOC will take only one parameter. So in order to have an encapsulation, what we do, we specify multiple keys in a list. So you can see there are a list within a list, right? So let me just give spaces here. So here I can specify again in any order. Let me add Saurav also. So location takes a single list and within a list you can specify multiple items. So this is how you basically view the list. Okay. So we can just see there are more number of methods. There is an iloc also. Iloc basically is integer location that again I will see in the later part. Now how to read data in pandas. Again it's a very simple thing, kind of an English command only. So we have reading data from CSV. Okay. So with CSV file all you need is a single line to load data. So let me see. Okay, first ensure that you have the purchases file here, right? So I have the purchases.csv rename file. Okay, let me just check whether this opens in a new tab. Oh, it's not opening. Fine. Okay, so PD is our pandas library and it has a function called read CSV. So if you want to read about it, you can just hover on the read CSV function. It will give you a huge number of parameters that you can use, right? And along with their help, write at it, right? So if you see, this is the top. So file path or file buffer, and then you have a separator. So right now, by default, the separator is comma. So if you want to read anything about this, so you just go to Google, type pandas, read CSV. You can read the documentation about this. So I will just go through one documentation quickly. Okay, so read CSV takes so many parameters, delimiter, header, names, index call. And within that, for example, if you see our notebook, let me just close the other windows. So I am only specifying purchases.csv. See, I didn't specify whether the delimiter is comma, semicolon or something like that. So no need to get confused. You can just come here. So you can see the delimiter, right? So default is none, but basically Pandas is intelligent enough to assume that by default, I have to take comma. Fine. And you can read about what are each and individual parameters here. A good way to learn is to go through. For example, index column will be used. So index call, it says columns to use as the row label of the data frame. We will just come across this in a while. Right? So now if you see here, when I read the purchases.csv and I'm displaying this, it says unnamed 0, right? So what happens if you don't specify an index, right? I didn't specify any index call, index underscore call equal to, right? So this basically was blank on my side. So if this particular column is not specified, pandas will automatically add an index column, right? 0, 1, 2, 3. So let us right now just skip it and continue execution, right? So CSVs don't have indexes like our data frame. So we all need to do is to just designate an index column. So now I'm saying key, okay, if you see this is unnamed and it gives basically the column number, right? Because this did not have any header with it. So now if you see read.csv, I'm having purchases.csv and index call is equal to 0. That means the 0th column I need as index. Now you may say, why is this not column 0? Because this is an internal index for pandas, right? This is not a column. This is an internal index that pandas maintain for its own execution. This is column 0, column 1 and column 2. So I'm saying, okay, I need the index column as 0. So now pandas made this as the index. A quick way to see is that, for example, if you have much data, pandas will make the entries of index in bold, right? Initially, this was the index. So 0, 1, 2, 3 was bold, right? Finally, we said, okay, make column 0 as the index. Now, Sachin, Saurabh, Dravid and Lakshman are bold. These bold entries indicate that this is an index column, right? Not a data column. Here you can see Sachin Saurabh was not bold. This was bold. Okay. Similarly, nowadays you have a JSON format. So in the JSON format, JSON is almost like a dictionary format only. But I'm skipping this part because we are dealing with only CSVs today. But just for the namesake, let me show you the function. So read JSON, and again we are reading the same file purchases.json. Okay. Again the same thing. Underscore read underscore CSV is replaced by read underscore JSON. Similarly, you can read through an SQL database. This, of course, is a quite advanced feature, but for that you need PySQL Lite, right? So not a MySQL, it does support MySQL and MongoDB, but again, for the sake of completion, install this library. So right now we are skipping this, and you make a connection to the database.db. So you can see here we have database.db file. Okay. So whenever you are doing something in Colab, at times if it is not able to read a file, come on that particular file, click this 3 dots and just select copy path. Okay, so once you select a copy path, you can directly come inside and paste this particular path. Right? By default, Python will keep the slash content and the file name in order to read a file. Right? So try to give the file name first. If it does not read, for example, it is not able to read the new purchases, click the 3 dots, copy path and just paste the path. It will read successfully. Right. So the standard query for reading into any database, select star from purchases. So this was a database. So I'm skipping this particular part and converting back to CSVs, JSON and SQL. So at times it happens that you directly work on a given data frame. But if you want to export it to a CSV or JSON or SQL so that the users can see it, so you have a function df to CSV to JSON and to SQL, right? So whenever you are passing to SQL, you need a connection to the database also, right? So I think we are 35 minutes. So I think we can take a small break of 5 to 7 minutes and then we can be back. You can raise hands or ask directly.
Mayank,
Yes.
I think they have already done the pandas. So parallelly, in 5 minutes they can execute this, right? They can come to your.
Right.
Okay. So should I go through pandas or no?
They should tell actually. I think they have covered.
Sir, actually, we have done experiments related to this. We are looking forward more for time series analysis. If other
Acha,
participants
okay.
also.
Yeah, I am okay with it. So let me. It depends on them completely. I am okay. I have Sarima, Arima, and all.
These are the untouched topics, so we are excited to learn about them.
Acha, okay. So let me then go here. Okay, then I will jump into time series. Did they do exploratory data analytics, like how to handle missing values, non values, and all those things?
Yes, sir. Is null, top na, fill na, so that was covered.
Acha, that was covered. Okay. So we'll begin in 5 minutes. Let me just. Okay. So. Okay, class. Is the slides visible? Time series analysis, properties, and predictions.
Yes, yes, yes.
Right. So I have a separate slide on too much mathematics. So right now I'm skipping that. Right. It may get some boring, but okay, we will see the basic properties of time series and all. Sharing screen. Okay. Okay, just let me try to execute in this, but okay, so objective of time series basically, okay, first of all, what is time series? We will look at it. So these are the small objectives that I have prepared: data description, interpretation, modeling, control, prediction, and forecasting. So we will also see the algorithm, right from the basic algorithms to something on deep learning and LSTM, which will be more of a black boxes, but we will see how to execute the codes and all. So time series data. So a time series, as the word says, so we have time related information and the data, right? So you have both the time and the data. So time series interval can be annually, quarterly, monthly, weekly, daily, hourly, even by minute wise, because so many times the weather data is calculated every minute, but the time component is there, right? So date is also a kind of time component. So for example, a very small example would be year and the sales, right? So for example, in the year 2005, we had a sale of 75, 2006, 74, and so on. Now, why this is a time series data? Because we have a time component which is in the form of a year, right? So if you plot a time series data, how would it look like, right? A time series plot is a two-dimensional plot of time series data. So for example, this is a standard example for US inflation rate. This is again a year, and this is basically the data. So when you plot any time series with a data, it becomes a time series graph, right? On an average, usually you keep the x-axis on the year because the scores are increasing, and y-axis is the data because this range can be fixed. Now, a time series is interesting in a way that it has four main components. We will look at them one by one. So first is the trend component, right? So for example, how do you see a trend component? Trend is something, for example, these days we heard Twitter trends, right? This hashtag trended. Trended means it probably become very much famous in a given set of duration, but then over time it will come down, right? Then it has a seasonal component, which is also like regular periodic fluctuations, usually within a 12-month period. 12 months because we take 1 year as a standard time in time series, but it can be a decade also. Then you have a cyclic component. So these are difficult to identify. Cyclic components is repeating swings of movements over more than a year. And irregular is something like erratic or residual fluctuation. We will see each of them one by one. So what is a trend component, right? So long run increase or decrease over time, right? So for example, if the sales forecast, if you see, so the sales were at this point in the start. Let me use the pen. So sales were at this point. So it increased to this particular point and then it fell down again. Again, it increased for a particular time, fell down again, and again it increased, right? So, but overall, if you see this blue line, the trend, if you see from the starting point to the point towards the end, it is showing an upward kind of trend, right? Increasing only, although with respect to this particular point, it falls, but we see it from the starting point, from the baseline where we began. Similarly, there can be a downward trend also. If the sales were at this point, maybe it increased, but eventually it fell down and it came to this particular point. So this will be taken as a downward trend, right? So for example, when there is a hashtag which is suddenly trending on Twitter, so what happens? You define a particular hashtag, right? So you can say this is the time and the number of Twitter comments with this particular hashtag. So initially it will be less, but when it starts trending towards the hashtag, basically what happens over time, the number of hashtags basically increase. So this is called as a trend component, something which is trending, which can be increasing also or decreasing also. So it shows a trend scenario. Then of course, a trend can be a linear as well as non-linear, right? So mostly it's non-linear only, but we can have cases of linear where the data does not fluctuate much, right? So for example, in our colleges, we have a student index which is usually increasing year by year, and that can be a linear trend because not much of an increase is there. So a linear trend is something where you can draw a line of regression. A non-linear trend is more harder to predict, right? So this will have a polynomial line of regression. Now we have a seasonal component, right? So seasonal component is something, for example, the sales. So if you see here, during the winters, there is a rise in the sales, right? So you can see there is a rise in the sales, but during the springs, there is a fall in the sale, right? Spring or a fall, there is a fall in the sales. So in this, you can see there is a typical behavior which is observed during the winters and the summers, and a typical behavior which is observed in spring and fall. A simple seasonal component would be like something. For example, in the summers, the sale of air conditioners tend to have an increase as compared to the winter season or a rainy season. Right. So it would be something like, for example, the sale of air conditioners. People may still buy during rainy season or winters, but when the summers come, the sales will shoot up. In the rainy, it may come down. Again, during the winter, something similar. Again, during the summers, it will shoot up and then come down, something like this. Right. So these are summer seasons. Right. So in this case, these are the summer seasons. So there are, of course, many examples. So for example, if you see the children going to schools, right? If you plot a monthly data, so usually they have a winter vacation in December and they have a summer vacation. So student, if you see the bus capacity, so in these two particular months during the summer vacation and winter vacation, it will go down, right? Because the students are at home. So again, this is pertaining to a season, right? Then we have a cyclic component. So cyclic components usually are a very big challenge in time series. So for example, we have a long-term wave-like pattern regularly occur but may vary in length, right? So if you see for this window to this window, you have a pattern here, right? But these are usually difficult to identify. Why? Because these pattern may be a set of small patterns, right? Or a huge pattern in its own self. That is the challenge here. And because of these cyclic components and of course noise components, there is difficulty when you predict time series. So often measured as peak to peak or trough to trough, right? So as I said, so in this particular example, see this is kind of a peak if you compare these values. So it is measuring between peak to peak. And then we have irregular random component. This can be treated as noise also. So unpredictable random residual fluctuations. So noise in the time series. The truly irregular component may not be estimated. However, the more predictable random component can be estimated and is usually the emphasis of time series analysis. As now there is a word here, stationary time series. We will look at the term stationary. So there is stationary time series model such as AR, MA is moving average, auto-regressive is, I will explain, ARMA, etc. After we filter out, trend, seasonal and other cyclic components. So a complex definition, but we will try to ease out. So we have two simplified time series model. So main is non-seasonal model with trend. So basically it means it has a trend. So if you see this particular chart, so a time series is composed of time series is equal to a trend component plus a seasonal component plus a cyclic component and plus an irregular component, right? So for at least these three, we have some kind of definition or some kind of algorithms with the help of which you can identify it. This becomes the most complex part of it, right? So let us go here and we see. So we have non-seasonal model with trend, right? So we had a trend component, we had a seasonal component, we had a cyclic, and we have an irregular component. So it says trend is there, but non-seasonal. So seasonal is not there, right? And then we have classical decomposition model with trend and seasonal, right? So we have a trend and we have a seasonal. They don't mention about cyclic because usually difficult to identify. So cyclic and irregular is simple noise, right? So there can always be a noise in the data associated with the machine learning algorithms. So the usual procedure is to first filter out the trend and seasonal. Now we will understand why do you need to filter out the trend and the seasonal component, and then fit the random component with stationary time series. Again, the word stationary is coming here. We will see it later. So if necessary, the entire time series can be reanalyzed for better estimation, modeling and prediction. Again, we will look in the tutorials here. Right. So first we have non-seasonal models with trend. So how do you define a non-seasonal model? Right. So given any process, right, this can be anything, number of passengers traveling into an airline or the number of milk products sold in the particular month. So it will have some kind of trend and some kind of random noise. So noise will always be there, right? So don't worry about the noise. So we have a trend component. So for example, here we are defining MT, YT. So we are defining in terms of a constant and this, a trend component and a noise component. See, YT remains the same. This we will again see in the next slides. So if you see classical deposition with trend and season and go in the previous slide with trend. So you can see with the trend, since the season is absent, we have only two terms, the noise and the trend. And here we have the seasonal component. We add a subscript of t here because everything is with respect to a time, as it's a time series analysis. Fine. So from mathematically, of course, I'm not going to the deep of these explanation, right? So they try to decompose a seasonal component and the trend component in this following manner. Right? So non-seasonal models with trend. So there are two methods by which you can estimate this: trend estimation and trend estimation by differencing. Right. So first we estimate the trend either by a moving average, smoothing or regression analysis, and then we remove it. We will see an example I have in the slides. So for example, trend estimation by regression analysis. So what is a regression? So for example, if you have, just a minute, let me choose another color. Alright, so let me say this is kind of a graph that I have, pen and so let me have some points on this plane. Right? So I can draw a line of regression, something like this, right? So this is kind of a trend which is for a good line would have been actually this one, something like this. So what happens? Estimated trend line using regression, right? So how do you do that? So if you saw in the previous slide, let's say we have the year data and we have a sales data, right? Right now, just ignore this particular column, right? So we don't have a time period like this, just ignore this column. Assume we have a year data and we have a sales data 20, 40, 30, 50, 70 this. So now if you want to estimate the trend, whether there is a trend present in this or there is a trend absent in this. So what we do, we use time as an independent variable. So what does it mean by independent? It means that the original data did not have any time domain in it, or it did not have a time because it had a year, right? It had year in terms of time information. So now what we do, as we saw here, we are adding a time period tree, which is an independent variable, right? What do you mean by independent? That addition of this time does not affect the value of this nor the value of this. So now if you see, I have now two columns which I can plot in terms of X and Y. Right, just see the next slide for it. So if you see, when I added period, so for period 0 I am having a sales of 20, right? So for period 0 I am having a sales of 20. It is just like a simple XY plotting on a 2D graph. Then for period 1 I am having sales of 40. So if you see, for the period 1 I am having sales of 40, right? Similarly, period 2 I am having sales of 30. For period 2 I am having a scale of 30 and so on. So once I plot all these lines, I can see basically this definitely has a trend, right? You can see now it is having an upward trend, because if you see, the line of 20 was here and the peak point was basically this. So I am having an upward trend in this. So this is how you this is one of the methods by which you identify whether the trend is there or not there. Right? Similarly, like fifth point corresponds to 65, fifth point is corresponding to 65. Now in time series prediction, so let's say you have only this data. So you plotted a line of regression here, which we have obtained, and we get the equation line equation, right? This can be easily calculated because it's something, this is simple line equation, right? Y is equal to, this becomes my slope, mx plus c, right? Or c plus mx, however we define the line, right? So if you see that we have a component t here, which is nothing but the second column. So in the next year, let's say 2010, if we want to predict, because if you see our data was only till 2009 and having 65 units here. So for 2010, what I'm making, I'm making the t as 6, right? Because it is just following 2009, which was 5. So if I had 2011, I would have taken here 7. 2011. So I will estimate. So in the previous case, if you see, I had this t here. So now I'm replacing the t with 6 and I'm getting the value 79.33. So this is my estimation based on the previous data, right? The most simplistic model. So based on the previous data, I estimate that for the sixth season, my sale will be 79.33. Fine. Second thing, this trend elimination by differencing. So differencing, if you see, define the lag minus 1 difference operator. So if you see the definition here is for a given xt, the delta xt will be current observation minus t minus 1th observation. Right. So just forget the term backshift operators and all. I will just say you what is meant by differencing. Okay, let me just escape this. Okay, so let me just reproduce the data and save this. So 2004 and we have 2005. 6, 7, 8, 9, 10. And let's say I'm just putting some random figures here 45, 52, we have 61, 74, 70, and 34. Right? So basically, this is an observation. If you see t, this is a time observation 0, 1, 2, 3, 4, 5, 6. So when I say we are using the differencing operation, so obviously we saw how can we plot a line of regression in this case. Fine. So when I say differencing, yeah, lag of 1. So what do I do? Basically, I paste this data in this particular column. A lag of 1 means I have the same series. So let me copy this particular series, right, and paste it in this particular fashion, right? So I'm just having a lag of 1. Lag of 1 means I am placing this whole series again. So I just do a copy of this series and paste it on here. So I have no value here. So this will be defined as nan, which is again not a number. And same for this, right? Because we don't have the previous data. So when I say a differencing of 1, so this basically, because I cannot subtract nan minus 56, right? So this becomes a not a number. But for these operations, I can definitely do a one order differencing. So 45 minus 56, and I can place it here, right? This will again be nan. So this is known as the first order differencing. Another method to identify trend. We will see in autocorrelation and partial autocorrelation how can we use these concepts. But just remember how is the differencing calculated. So for example, if someone asks you, okay, I need the second order difference for this. Second order means if I can just copy the data, I will leave, because it's a second order difference, I will leave gap 1, gap 2, and then paste the data here. So I will just copy this, paste here. The last two entries won't have a meaning because the previous data was not able. Right? So now when you calculate the difference, 52 minus 56, so this is the second order difference. So usually third order difference is usually enough to identify the trend. We take the first order, then second order, and then the third order. So this is how differencing is calculated. So it's easy only, but when you look on this formula, it feels quite complex. Xt minus xt minus 1. So you can see between two time intervals is the difference. Again, so we can take this up to kth difference, right? So if you can see, the k is defined in terms of k minus 1. So I can go up to any level. Okay, this is the theory part. I am skipping this for a while. Let me come to the stationary, right? We were seeing the term stationarity of the time series, right? So all the basic models that basically work on the time series assume that the time series is stationary in nature. So when I say it is stationary in nature, I mean to say that it is having constant mean for all time steps, and we will look at this constant variance for all time steps. So on internet you will find definitions having constant standard deviation also, right? So basically standard deviation is nothing but square root of variance. So if you are having constant variance, that itself means you are having constant standard deviation, right? But what is more important? These two things should be satisfied. Constant mean, right? Mean is same as average, right? So in computers we use mean. In normal language we say average, right? So this is how you define a stationary time series. So for example, let us look at this non-constant variance. Okay, so what happens here? So if you see this time series, if I draw a line here, right? So I have a kind of a constant mean here, right? So at this particular point, I have some upper peaks, some lower peaks. So the mean will be around this only, right? But what about variance, right? Along the mean, how much is the values deviating? So if you see here, the deviation is very small. Here it's a bit higher, more higher. This is having the highest deviation, right? So it means there is a huge amount of variance from the mean, right? So that it implies that it will have a huge amount of standard deviation also, right? So since it is not constant, it is less here, a bit more, more and more. So this is not a stationary time series, right? And now if this case, if you see, if I draw a non-linear trend line here, so if you see around this line, the deviation around this line is almost the same, right? Nearly the same, right? So basically this constant mean means it's nearly constant, right? But if you see, the average at this particular point will be too low as compared to the average here. So this says non-constant mean. Again, it's not a stationary time series. So in this particular case, if you see, this is a perfect example of a stationary time series. So you have a nice mean here, and the deviation along the mean is also, you can see it's quite uniform. So now why do you need stationary time series for stationary time series models? Because intuitively I will just explain the reason behind it. So as you know, the standard time series, right? So in any kind of prediction, what basically do you do is you assume that this is a stationary time series and you try to learn, right? Okay, my trend is going, then coming down and all this. So now assume that from this particular point, my series goes like this in a higher trend, right? So if I divide my series into two parts, in the left hand side, here this is the LHS and this is the RHS, right? So you will see from your own eyes that if I learn till this particular point, I am having a stationary time series. Whatever I learned on this model, if I try to apply on this particular model, it will definitely not apply, right? Because this is having a trend here, this is having an increasing mean also here. So stationary time series assumes that, okay, first make a series stationary kind of, right? And then you apply the model so that my learning is good in that case, or else my learning will be bad. It is just like, when you train your model on, let's say, data X, and then you have a completely different model that you apply on Y, right? So stationary, just remember two things, constant mean and constant variance. If you just plot, you can actually get a very good idea that, just a minute, pointer option, erase all link. So usually when you look at a particular series, you can get an idea whether it is stationary or non-stationary, right? There are methods, augmented Dickey-Fuller test and KPSS test. We will actually see this particular test when we work in Python. Okay. And now we have the autocorrelation and partial autocorrelation. Okay. So what is the intuition behind autocorrelation and partial autocorrelation? So if you see auto basically means self. If you only take the word auto means self. And correlation is our standard Pearson correlation, right? Remember we had X and Y. So we can have like 10, 20, and this can be some values, 15 and 35. So we try to compute the R value, basically correlation, right? A correlation of 1 means a very positive one. So that means if the X value is increasing, the Y is also increasing. This will have a standard correlation 1. And if you have the reverse one, right, this will have -1 because as X is increasing, the value of Y gets reduced. A zero correlation would be something, there is no trend, something like this. So these are the 4 points in space, so you cannot conclude because in this case, X is increasing, Y is increasing. In this point, X is increasing, Y is decreasing, and similarly for this. So autocorrelation function is the correlation of a variable when lagged value of itself and when a variable is linearly dependent on its own past value. See, on an intuition level, time series has a major assumption which is also true by intuition. Like, for example, when we see our initial data, sorry. Intuitively, if you see, the sale in 2006 will actually depend on sale that happened in 2005. It will have at least minimal impact on it, right? So the current data, right, depends on basically the data which we had in the previous time zone, in the time series, right? Maybe an year, month, or something like this. Now, if you see, let me just take a different color, pointer options, ink color. Now, when I say the data in 2009, basically has some dependence on data in 2008. Similarly, data in 2008 depends something on data in 2007, right? So in a way, 2009 actually depends on 2008, and since 2008 depends on 2007, 2009 also depends on 2007, right? So there is kind of a relationship between the past data that we are calculating, and that is what we basically do in autocorrelation and partial autocorrelation. So just let me explain you here. So in autocorrelation, what happens? So for example, in this, let's say in the same example. So this is the, let's say the sales in 2020, right? Something happened and this is a sale in 2019. And this is the sales that happened in 2018, right? So let me change this color. So when I say autocorrelation, right, so autocorrelation will basically see, okay, the sales that happened in 2019 had an impact on the sales in 2020. So this is, you can get it through like the ACF. Sales that happened in 2018 has an effect on sales in 2019, obviously. And also I can have a relation directly here. Sales in 2018 may have some effect on sales in 2020. Okay. So in partial autocorrelation, what you do, for example, if I want to have the impact of 2018 on 2020, I basically will use the partial autocorrelation. So partial autocorrelations ignores all the middle components. So it will only take only two components at a time. But what will autocorrelation do? Autocorrelation is self-correlation, right? So basically, if you see 2020 will have a correlation with 2019. And since 2019 has a correlation with 2018, 2020 will have a correlation of 2019 as well as the effect of 2018. And this is what we meant with the first order difference that we were seeing here. So when you will execute, you will get an idea. For example, okay, let us have a hands-on session. So let us come back to our browser and come to File, Open Notebook. You can come to T3. Okay. Let me again open the GitHub notebook. You can come to the T3, PyData, Arima and Sarima. Okay, so we will see here two models, Arima and Sarima. Basically, Arima is the parent, Sarima is just seasonal Arima. So as we were seeing, we have a trend plus data and we have a trend plus season plus data, right? So I hope everybody is okay with this notebook and you are able to see. Let me just see whether I have my files here. Okay, let me just connect to it. Okay, so okay, before beginning this notebook, let us take a gap of 5 minutes. I just have some water and come back. By the time, just ensure that you have loaded this notebook, Arima and Sarima. Okay guys, so we are back to our Python notebook, and I hope it is a complete notebook in itself because I used wget to download the dataset, so I think should not be an issue. So first let us install the Arima package. So pip install pyramid Arima. So it may give a warning, just authorize it. Okay, so it successfully installed the pyramid Arima package, and now let us get the airline passenger data. So first let us view the data directly in the browser, right? So this is the airline passenger data, and if you can see, this is again a year and a month, right? So this is like January 1949. So the total number of passengers traveled by air were 112, fine. 1949 second month is 118 and so on, right? So it has till 1960 and 12. Right. So basically from 1949 till 1960, so we have a 12-year data, and for each of the months, right? So we have 144 data points here. So now let us read it into our model. So I just press Control Enter, right? So a small file only 1.7 KB. And now we will import the useful libraries pandas, numpy, matplotlib for plotting. From pyramid.arima import autoarima, right? And then from stat models, we are importing these two important libraries, plot ACF and plot PACF. So basically this is plotting the autocorrelation function and plotting the partial autocorrelation function. This definition we are just executing, but I will explain you what is mean absolute percentage error. So these are the different metrics, right? So basically when we do prediction, we are kind of forecasting the future values. And then we will see how do we compute the matrix. So first of all, let us read the air passengers data and just have a display of it. Okay, PD is not defined, so I think I did not execute this box. Okay, this box is executed. Let me execute this function. It will be useful in the future. Now let me re-execute this box. Okay, again you see Pandas has added an index column here from 0 to 143. So total we have 144 rows and 2 columns. So now let us plot this figure, right? So I'm using directly the column name has passengers because we had passengers in this column. So now you can definitely see there is a trend component here, right? You can see these peaks, right? So this data is not stationary. So from the looks also you can directly get a feel that this data is not stationary. There is a trend here, right? There is an increasing trend, and which is quite visible also, right? So as the airlines became more common, more airlines company came into the picture. So from 1949 to 1960, this figure will have a rise only. So this did not have a this is not a stationary time series. So now let us first do one thing. Okay, let me just go here and just check for the Arima model. Okay, so even though it has a trend, let me calculate. Actually, Arima. Okay, just okay. So in any machine learning or AI model, when you want to predict a data, right? So first you need to have a training data. So what do I mean by training data? So basically you are telling the machine ki, okay, this has been my observations for the system. Now try to learn insights from the data, and then I will give you a new data on which you will do the prediction. So here the term new data is a bit confusing. I will explain you what do actually we do. Right, let me just start PowerPoint, take a new session. So let us take a very small data only. We just take a 12-month data. Let me just paste this in PowerPoint. Okay, take. Let me remove this. So how is a machine learning algorithm learns or evaluates to learn, right? So what happens? So for example, I have your 12 data points, right? So you must have seen, if you have been familiar with machine learning and all, we give some data for training and then we ask them some data for testing. But then how is the prediction actually going on? So let me just insert a shape here. So let us take 70%, right? 70% of 12 is roughly 8 values. 7 12s are 84. Okay, let us keep 60%. 7 data points. 66 12s are 72. Okay, 7 data points. 7 12s are 84. Let us keep 8 data points. Okay, let me just put a transparent color here. So in any machine learning or time series or any prediction method, see, I had a total of 12 data points here, right? So what I say to the algorithm is like, okay, even though I have 12 data points here, you pick up 8 random data points, right? For simplicity, we are assuming that we are picking the first 8 points, but in the actual algorithm implementation, it may differ, right? It may be alternate points or any random 8 points. Let us keep things simple. And then we will say the algorithm ki, okay, I have my time series data. These are the 8 points from which you need to learn ki, okay, and predict the future. So internally what happens, the machine learning algorithm will learn from these 8 points and then we will ask them ki, okay, now please predict what will be the value in these 4 boxes, right? So let me take, okay, insert shape, insert shape, and let me keep this in a different color. Okay, so this becomes my training part. So this will be my, oh sorry, this becomes my training part and this becomes my testing part. Right? So what does the any Arima, Sarima or any other even deep learning algorithm? So what will they do? They will take this, try to understand, try to make a trend or any, basically they usually form a regression algorithm in the background. And nowadays with deep learning, they can form non-linear models also. And then they will try to predict this. And the beauty here is that when they come on the testing data, see, we actually know what are these values. So we have 136, 119, 104 and 118. So when the model is trained on this particular data, we ask them ki, okay, now predict for these values, right? So let me just again note down, we had 136, 119, 104 and 118. Just for simplicity, assume that by learning the about data, the model had predicted these values. So let me keep that in red. 135, 114. I'm just writing some random values. 124 and 118. So let me just mark this in red. Right. So the machine learning algorithm says that, okay, I studied your 80% data. And according to me, if this is the trend that is being followed, your these 4 values should be that I have predicted in red. Right. And how does the evaluation matrix then work? Because you already had the data for this, right? So what was this value? 136, 119, 104 and 118, right? So let me just mark this as in black. So now what happens if you see we are not providing any futuristic or new data for machine learning algorithm to learn. From the existing data, we split the data into training and testing. So when the model evaluates itself, it assumes as if it does not know these values. It will predict, and then for example, if I see the error here, so 136 minus 135 is 1. Then 119 minus 114 is 5. 104, sorry, 114, this will be minus 5. 124, this is 20, and this will be 0. So this was a perfect prediction. So in ML algorithms, we usually take the absolute value. So absolute value will be all positive value, 20, and this will stay as 0. So if I take the average absolute value, right, I will also tell the concept why do we take absolute value. So this is 20 plus y 25 plus 1 26 plus 0. So 26, and how many entries are there? 4 entries. So 26 divided by 4, which gives me 6.5. So my mean absolute error is 6.5. Right, so that means in my prediction, I may give a plus minus 6 units difference. So if the actual is 135, I may predict 130 or 141, right? And now why do you take absolute errors and why not like the logical error? The reason is, for example, let us assume this value is 130 and this value is 119. Let us take this as 114 and this as 128. So if you see, the difference in these values will get cancelled out. So for example, 135 minus 130 gives me 5. 114 minus 119 gives me minus 5. 124 minus 114 gives me 10. And 118 minus 1.5 gives me minus 10. So had we not taken the absolute values, so when I add all the errors, basically my error comes out to be 0. 5 minus 5 gets cancelled, 10 minus 10 gets cancelled. Right. So the evaluation would have said that, oh, the model is completely perfect, right? There is no errors, but in fact, there is a error in every value. So when we compute this and convert it to a absolute value, the error basically gets determined. So we have 10, 20 and 30. 30 by 4 is 7.5. That is the mean absolute error. Right? So this is how models actually work. The entire data set is divided into training and testing phases. So now if you see, the length of DF is being calculated. So let me just insert a cell below so that I can show you line by line. Okay. Right. So when I calculate the length of this data set and I print print, you can use control space to autocomplete. Right, the data length was 144, and now see what I'm doing here. The data length, what I'm doing, train data length. So I'm defining it in a variable known as train data length, and I'm asking it to calculate 75% of the data set to get the size of the training length. Right, so what it will do, data length in the previous case was 144. So it computes the 75% of 144 and I typecast into an integer, right? So that I can avoid the floating points and then store the train data. So since I had 144 rows and I trained the data on the 75% of 144, the remaining 25% I'm assigning it to the test data. So see what I'm doing, data length, which is 144 minus train data length, which is this, which is nothing but 75%. So let us just displace all the three statistics. So 144 is there. So training gets 108 values and test gets 36. So you can see 108 plus 36 gives me 144. Fine. I hope it's clear till now. So now again you divide the data frame into testing and training. So for example, for training, you are taking from the starting point up till the train length, which means up till 108. If you are having confusion, I am adding here 108. And for testing, what you are doing, you are starting from the training data, that is, you are starting from 108 and going up to the end. Right? I hope till this point it is clear. Now, what do? We now plot the autocorrelation and partial autocorrelation. So you will have two graphs. So I'm choosing the passenger column. So you can see here we have the second column as passenger column, and you get a similar graph like this. Right? We have a partial autocorrelation and we have an autocorrelation. So autocorrelation means the series onto itself. So for example, if I have this one, so let me save this as a CSV file and open in Excel. hairline data. Oh, sorry, hairline.csv. Right, so this was my passenger data. So now if you see these graphs, right? So in the first instance, you have an autocorrelation value of 1. You can see on the y-axis, you have 1 here, and this first line represents this one, right? So when I say, and these are basically the lags. So let me just say you, so what happens when you calculate the autocorrelation with 1? Oh, sorry, this is insert one row above. ACF right? So what happens when you calculate the autocorrelation with the lag of 0, right? So you can see this is lag of 0 basically corresponds to this particular line, right? So let me just annotate here. See, this basically corresponds to autocorrelation with a lag of 0, right? And then you get a correlation of exactly 1, and which is obvious, right? Because when I see here, and lag of 0 means when I combine this data along with itself. Fine. So what happens here? When you calculate the correlation of these two columns, it will definitely come out as 1. Right? I mean, simple mathematics that we study in engineering, calculating correlation between two columns. If those both are exactly identical, right, the correlation will be 1, and which you can see in this particular graph. Now, when I say ACF with a passenger lag 1, so what happens? With a lag of 1, this first value will be shifted to the second column, right? So you can see 112 is here, 118 is here, 132 is here. So this will become NaN, and the last value for this will become NaN, right? So what will be the useful thing? This will be the useful thing, right? Okay, so I am ignoring the first and I am ignoring the last term, right? So now I calculate the correlation between these values. So this with a lag of 1 is having this correlation. So you can see this is slightly smaller than this, and which is obvious, right? Because already we lost two values, and then the correlation will slightly fall here, right? You can see there is a slight fall, and then there is a sudden increase here, and then it is again falling, right? And again, partial autocorrelation, as we say, partial will not see the intermediate effects. It will directly plot the graph between like lag 1 and lag 10, lag 1, lag 12, lag 1, lag 13. Again, it has the same lags, right? 0, 5, 10, 15, 20. So now what we do here in Arima model, we have to pass 3 parameters to the model. So let me just write, I think I have written a comparison here. Yeah. So building the Arima model, right? Why actually we calculate autocorrelation and partial autocorrelation. So Arima model basically takes 3 values. We have a P value, we have a Q value, and we have a seasonality, right? Basically, this is called M or D, depending on the convention. So if you just check this particular blue line, right, in partial autocorrelation, this basically begins with a lag of 1, right? In this blue line, if you see, lag of 1, just ignore, that is the first value. So this point is outside this blue shaded region, right? So that says ki, okay, this value is highly correlated, right? You can see the correlation is almost 0.9, I can say. It comes out to this point. And if you see the moment it falls below 0, it means from the third, this is the second lag, this is lag 0, lag 1, and this is lag 2. So lag 2 had a negative correlation, right? So we just ignore those lag 2s and all. Similarly for here, so you can see we have a higher correlation here, but initially a golden rule is something like for P and Q, right? You try to keep it first order or second order difference. You don't go beyond that, because beyond that you don't get much accurate results. So just a second. Okay, so back to the model. So we have a start value, the minimum value of P we want to try, the max value of P. Similarly, the minimum value of, okay, this is Q actually, the minimum value of Q we want to try. And seasonal equal to true means the time series is seasonal, right? So when you define the auto Arima model, basically, so why are we defining seasonal equal to true? So you can see we are having either seasonal equal to true. So we didn't calculate the Dickey-Fuller test, but since we had plotted the graph, so you can see there is a kind of seasonal in the graph, right? There are peaks in between. So this specifies that the graph was seasonal in nature. So we are asking the Arima model, ki, okay, take care, the model is already seasonal, right? Similarly, for P value, we are having a start value of P as 1, a max value of P as 3. As I said, ki between the first lag and the third lag, enough information is usually captured. Something like when we do a normal distribution. So between mean and +3 standard deviation and -3 standard deviation, we say that, okay, 95% of the data should lie within these two boundaries. Similarly, for Q, I'm starting from 1 and going till 3, right? So for differencing, I'm taking 12. So why did I take 12 in this case? Because 1 year corresponds to 12 months, right? I have a yearly data, 1. So there is a possibility that 1949, the January of 1949 may be related to the January of 1950, right? And hence this M value, right, the seasonality of the data, right? So we have to, since we are saying the seasonal is true, a season can be every 3 months, a season can be every 6 months, right? So for example, if you take the example of elections, right, so the number of people that have voted in an election, so in that case we will have seasonal as true and M as 60, because a season, election season comes every 5 years, which is nothing but 60 months, right? Something of that sort. And these are like just some standard. So whenever you want to learn about a function, you can just hover on it and it will give you the complete documentation. What is this value? What is the start Q, max P and max D? So now if you see my P and Q value and D value, so it takes 3 parameters, P, D and Q. So what happens here is AIRMA, Arima model is there. So for AR, you require the P value, which is autoregressive. For integrating, basically it requires D/M, basically differencing, sorry, it requires a D value, the differencing value, and MA, it requires the parameter Q, right? That is the moving average. So for differencing, we are saying a difference of 1. For P, we are saying starting value of P is 1, max value of P is 3. For Q, we are again saying 1 to 3, and M, which is nothing but the seasonality, which is 12, as I said. We have a 12-month data. So now when I execute this, you can see it will go through a series of steps. Okay, DF train is not defined. I did not execute the above parts. Sorry. So I calculate the length. Right, length is calculated, then DF train. Then let me plot the ACF PCF. And now let me try the model. So basically auto Arima composes of both Arima as well as it takes care of Sarima. Okay, now how does it take care of Sarima? Because now you can see, as I said, for Arima, I require 3 parameters, P, D and Q, right? This is P, this is small d and this is Q. Now, if you will see, Arima went through so many iterations. Now, why did it go through iterations? Now you can see that D basically is constant here differencing is 1, right? So first order difference, as we saw that in Excel, first order difference is, a first order difference will be in this fashion, right? This is how it will be calculated. This is equal to 45 minus 56. Okay. So P and Q, since we are specifying the value, start P is 1 and max P is 3. So it goes from 0, 1, 2. Basically, it takes 3 values beginning from 0. Similarly, for Q, it goes from 1 to 3. So 0, 1, 2. So you can see P is varying from 1, 0 and 2. Technically 0, 1, 2 because max value from 1 to 3. And for Q, it again goes from 0 and 1. It did not try to. I will explain you the reason for it. And again for seasonal order. So seasonal order is basically where we include the seasonal component. So if you see this MS12, it is being captured in this particular thing, right? That the seasonality is to be calculated kind of mod 12, right? And then you have AIC score and BIC score. So this is Akaike information criteria. So Akaike information criteria says that your model will work best for the lowest value of AIC. So basically lower the AIC, the better is the model. So now let us see one by one. When I took P as 1, D as 1 and Q as 1. So my AIC was 707.520, right? Similarly, tried all the possible combination and now just check the model. 709, okay, 706 is lower. We got 705 as the lowest value. So just have a comparison here. Right, so if you see the comparison, the 705 is the lowest AIC value. So lowest AIC value corresponds to better models. Right, and now if you see what are the values of P, Q and D in this, see D was anyways constant, right? So if I see her annotation, if you see the annotation, D is always constant. And now if you see the P value and Q value, so the model performed multiple iterations, gave you the AIC value, which is the lowest here. So the value of P equal to 1 and Q equal to 0 provided the best model, right? So the auto Arima then tries to predict the time series forecasting based on P value 1, Q value 0, D value 1, and for seasonal, since our data is seasonal, it got the 0, 1, 0, right? Because as I said, just a second. This is for Arima, right? Fit order Arima if you see. For Arima, the time series needs to be stationary, right? Hence you see there is a parameter difference. For Arima, the value of P equal to 1 gave a better result as compared to the seasonal Arima. In case of seasonal, P equal to 0 and Q equal to 0 gave a better component because seasonal Arima, that is Sarima, is more conducive for seasonal data, and our data is already seasonal as we saw. So now this model performs the best. So auto Arima auto computes the, for example, I'm doing print model. So when I say print model, if you see, I defined model in a very generic fashion. I asked him key, okay, for P compute for 3 values, for Q also try 3 combinations, seasonal assume it to be true. So Arima and auto Arima calculated all the possible values, and based on the lowest AIC value, which in our case is 705, it gave me that model. Now when I print the model Arima, so it says I will compute this particular model. This is having seasonal as 0, 1, 0 because we had set seasonal equal to true. So if you see 0, 1, 0, 12 was with this one, AIC 705. I mean, it is automatically calculating that value which has the lowest AIC score. So nothing rocket science here. And now once your model is ready, the fit function will help you. So now we are saying, okay, once you train your data, now you want to fit the model on the trained data. Remember that you fit your model only on the trained data, right? For testing is for evaluating the model. For fitting the model, you provide the training data, right? Which is basically the 108 rows. So let us fit the model. Right, again, if you see the seasonal order is 0, 1, 0, 12, this was computed because this had the lowest AIC score. And you can see the order for Arima is 1, 1, 0. Again, if you remember, the AIC was the lowest at 1, 1, 0. Right? Same reason. And now you are doing the forecasting. So for forecasting, what do you say? Now our model is fit on Arima, and then you say model.predict. And now for prediction, you need the test data. So how many periods that you want to compute for the test for prediction, which is equal to the length of the test data. Let me hover this and it will give you the length as 36, which is nothing but the same values that you had got here. Length of the data is 144, training is 108, and testing is 36, right? So I say that from the model that you have trained, basically you have fit the training data, you have fit the 108 data. I want to now predict 36 rows, if you can see. So I want to predict the last 36 rows, whatever it may be. Fine. And now let me just execute this. Right, and now we will see the analysis, which is again, so as you saw, forecasting is just a 3-line code, right? You just say model.predict, the model is already defined above. And finally, what will be the model predicting? As I said, the model predicts these numbers, the number of passengers that traveled. So let me just plot it so that you can easy. So forecast.plot, right? So predicted number of passengers. So you can see this particular graph. Predicted number of passengers are in blue and actual number of passengers. So as I had explained you, we already have these actual number of passengers, but for prediction, we ask the machine to calculate the last 36 values. So you can see the orange and the blue line are nearly coinciding, but of course there is a huge error at some point. So let me just show you the points of higher errors. So you can see here, annotate, this one is having a very huge error. Right, again, this has a huge error. This has a small error, but does have an error here. This particular component was not being calculated very nicely, so there was much error. But if you see, this almost got predicted correctly. Right? So this is how, when we view the model, you get an idea of how the prediction was. And now then we calculate the error matrix, right? So let me calculate this. So we have mean absolute error and we have a mean absolute percentage error. So percentage error is basically calculated from MAE only. So if you see here, we had a mean absolute error of 70. So I already explained you how do you compute the mean absolute error. Right, so let us take a small variable. So let us say this was the actual, this was the actual, this was the predicted. Right, so what we do, actual minus predicted. So now we take this minus of this, right? And since we are having mean absolute, so we take the absolute value. So let me take apps. I will use the apps function here of Excel. Right, so these are the absolute values. I will do a sum of all these values. And how many entries I had? 1, 2, 3, 4, 5, 6, 7. So what I will do, 58 divided by 7, right? So this is how you calculate the mean absolute value. So in this case, I have got an error of 8 units. So given a predicted value, my actual value on an average, right? On an average will be in the plus minus 8 range. So if you see in this, it was a range of 6 which satisfies, 14 not satisfied, 3, 8 and 0 were satisfied, and this were beyond my average errors that was calculated. So indicates that these were quite high errors in the data. So now let us compute this. So now we are plotting the forecasted value along with the actual value for comparison. So now if you see, we had 75% data, right, for training. So this particular data will have only the training set. And in the end, we had the ones which we predicted. So that is y hat in the blue line. So if you can see in this particular case, except for some regions, the prediction was quite well done by the Arima model, right? So few things that you need to take care is every machine learning algorithm is very much data dependent and also very much trial and error based. So let us remember two figures here, two numbers basically, MAE and MAPE, right? Let me save them in Notepad. So MA, we had 4.3% error. So now let us try to make this as 80%. Okay. So let us try to make this as 80%. Now I'm saying that, okay, my error was a bit higher. So let me try with 80% data. So 80% of 144 gives me 115 and then I'm only testing on 29 data. So now let me, okay, this will now change. So let me not keep it this. These all things will remain the same because autocorrelation we are taking on the entire data. Right. So now if you see, since I did the 80% of the data, my AIC has changed. Right. So I have 757.66, 757.438. So I think this should be the lowest. Again, if you see my P and Q, basically I took the same order only. In spite of being 80-20, I got PQ this 110 and this was 010. Basically, I got the same model selected. So now let us see how the model fitting takes place. Okay, I think the error is increased. From the graph itself, you can have an idea. See, the error has increased. So in this case, it is 24 and let me write 75-25 training and testing. And this is 80-20, right? So in both, of course, MAE has increased. So basically training the data with 80-20 is not a wise approach, right? Always remember, whenever you do time series prediction, you have to go with different combinations here. And there is also a result of overfitting. Just for a case, those who don't know what is overfitting. So overfitting means you made your machine to learn a lot. So let me try to keep this as 99, right? So I'm asking the machine to learn 99% of the data. So let me just execute this. So in this case, the error may reduce, but your model may overfit. Let us see which is 110. Again, I think this one only.
Unmute.
Let me just execute the model. So this is kind of okay. Some error. Okay, trace back. I think 99 became too high a value, I guess. Let me just check. Oh, actually, see, this was the issue here. Okay, two are there, right? Test data is 2. So then I think the program should have run well, run all. Let us try again. Oh, sorry, I missed a hash here. Autocorrelation, building the model. So these are the precautions that we need to take care, and hence machine learning, even though it has changed our lives, this is more of a black box approaches, right? So it highly depends on the data that you have. So for example, if you have a good data with less noise, the prediction may be very good. But you cannot take that model and apply to some other model which is having a highly noisy data, right? So in that case, the error will increase. I don't know why it is taking so much time. By the way, you also can try with different values of testing and training and then come across, I think, take 10 minutes, try to have a different training and testing, maybe give 85, 87, 90, 95, and put it in the chat box if you are getting an error which is less than 4.35. I think for 10 minutes you all can try. Just try to run this notebook. So we will have kind of a break also, and you can try at least, trying hands-on has its own fun. Okay, somehow it is taking too much time. Okay, 998.
So there is one question in chat box, how we can decide the values of max P and max Q.
Okay, so for max P and max Q, you actually decide using partial autocorrelation and autocorrelation. So as I said, from the autocorrelation function, see, usually you start with the partial autocorrelation, right? So for partial autocorrelation, you will get the value of Q. Just let me check once, just to be very sure. See, whenever you plot a partial autocorrelation graph, you just check the correlation values, right? So this is at lag 0. So at lag 0, obviously it will be 1. So you just ignore that particular value, and lag 1 is having a very high correlation. Right, beyond this, if you see this blue color region, this basically, if you see the correlation here is less than 0.20 and in the negative range minus 0.20. So the moment you enter a value which is going towards the 0, at that time you stop. Even though if you see for a lag value of 10, you are having a decent correlation, or a lag value of probably 14, you have a good negative correlation. But the moment it trips towards the 0, you stop at that value. So in this case, you have an ideal value of Q. So in partial autocorrelation, you get the value of Q. You can keep Q as 1, but just because every time the model may not capture all the things, we take a value 1 or 2 higher than this. As I said, a differencing of 3 is usually enough for most practical purposes. So ideally, seeing this autocorrelation, I could have kept Q max as also 1. The answer would have been the same, right? So, but it's a good approach to keep up to 3 because third order differencing usually covers everything that you have. Similarly, for the value of P, you again check this particular graph, right? So in this case, if you see, we have a higher value of autocorrelation, but as I said, keeping beyond 3 will rarely improve the results, right? And just add to the complexity of the model, right? So people usually take from 1 to 3. So that is the answer for it. Mostly it is trial and error based, but partial autocorrelation can give you a quick view till what point you need to go. Okay, anybody tried and got a value MAPE less than 4.35 for a particular testing training? Okay, so this was a very bad fit actually with 99 and 2. No, 4. See, in this, even if I'm giving a 99% testing and training, there is hardly any error improvement, right? From 674 to 275. But please avoid giving too much data for training also, right? So in that case, what happens? Your model overfits. Overfit means it basically has learned everything from the training data, right? And there is a high chance that your error may actually increase, because if the data that comes in as a future prediction is too high or too low a value, then the machine learning model may completely garble up in prediction. So usually a 75-25 and a 70-30 is a very good model. And I remember that I had a cross validation also, or there is an approach known as cross validation, which I hope we will see in LSTM. I guess I have put it on. So cross validation is another method by which you can overcome overfitting, right? So let me just give an intuition of overfitting also. Again, a very important concept in ML. So let me just insert. Okay, let me just start paint. Brushes. Okay. So let us have a graph and let us have some points distributed here. So for explanation, we usually refer to the line of regression, which is the lines of least square errors, right? So what we do, let us take this line, right? So this is the line of least errors. So what does that mean? Basically, so if you have a line and a point here and a point here, so from this line, if you compute the distance for this point and square it, the difference will be the minimum. That is called a line of least square regressions. Fine. Now in overfitting, what happens? So for example, let us take 4 points, right? 1, 2, 3, and 4. And let us keep up 1 point. Okay, sorry. Let me keep the outlier point here. Let me keep the outlier point as here. Right. So normally when you apply for a regression techniques, the regression line will give you a line like this. Sorry, not like this. In between these two lines. Right. So if you see the error, basically for these 4 points will be small, but for this particular line, the error will be huge. In overfitting, what happens? The model will be something like this. Oh, sorry. Let me change the color. Model will be predicting a line like this. It will cover all the points, right? So even though it looks good in practice, but it has no practical value, because there is no guarantee that if I have another point like this, it may even be able to predict this line. It may simply go something like in this particular line. So overfittings are bad. So whenever you have some data, try to have 70-30 or 75-25 splits. So anyone tried for 85-15 combination? Any results? If you would like to share, you are free to do so. So please remember, in machine learning, the prediction models are very simple to compute in Python, right? Your entire analysis, your entire analytics or thinking will actually depend on how do you set up the model. How do you see the autocorrelation and partial autocorrelation and such things? Nothing much you can tune in the model. You can of course tune these parameters, but not much beyond that. Only depends on the data. So more importantly, you need to search for exploratory data analytics. Okay, how is the data? How much we are missing data? Can we impute the data? Can we replace the missing data with some mean values or median values or average values? Right? So that kind of analysis basically is more required here. So for the next notebook, let me just try to have. Okay, so you can open the T4 notebook. So T4 is a recent library for time series prediction by Facebook. So they named the library as Prophet. You can just try to Google it. So they say that it's very much easy library even for very much beginners in data science. So we also tried our hands with it. Actually, last week only I tried my hands on the same data. So always remember Arima, ARMA, right? This is like the most naive models, but they are so beautiful that they perform nearly well to some advanced models also. And that we will see in this particular example when we see the profit model. So just let us take a break for 5 minutes and then I come back. Oh, somebody got a very good MAPE. Just let me see in the chat window. Oh, for 98 and 2. Of course, the error has significantly reduced. Dr. Chetna, I appreciate your efforts. But for trying, it is always good to see how and have lower errors. But for model training, avoid this much of overlearning. One exception is there these days when people are working with CNN on images, right? So nowadays a very hot area is image captioning, automatic image captioning. So what do they do is based on the image, the deep learning model, based on the image, the deep learning models will try to auto caption an image. So for example, if a small kid is eating an apple, right? So the deep learning model will see the image and try to caption the image. A boy or a girl is eating an apple, right? So in that case, recent papers in CVPR, they have seen that they train 99% of the images using CNN and then they test only on the 1% of the data set. So in that case, just as a counter note, I don't work on images much, but just for knowledge per se. For images, you can have a very high learning. Okay, so just 5 minutes and then we will be back to the profit model. That is a time series analytics model by Facebook.
Hello. Uh, there is one small announcement. As you have session, ma'am, so she wants all of you to watch that video. Video link is already available on. You can go and check the video link. Because she'll be taking hands-on session on ANN, DNN, and CNN in Python. Ma'am wants.
Pallavi ma'am, sorry to
Pallavi,
interrupt.
Pallavi,
Can't
your
hear
sound
you.
is very low.
Am I-
You are audible, but it is very, very low.
Oh. Hello, ma'am.
Yes, yes.
Uh, so ma'am wants that uh, should watch the video. Video link is available on Moodle. Because she wanted to take the session of ANN, DNN, and CNN model using Python, TensorFlow, and Keras. And she wants that everybody has to be with a laptop for hands-on session.
Pallavi madam,
Yeah,
type this message in chat box and our WhatsApp group as well. Okay. This is for tomorrow, right?
yeah,
You type this same message in chat box and put it on WhatsApp group also for tomorrow. You write there for tomorrow. Okay.
okay.
For tomorrow's session and then you continue the message.
So hello guys, so we will now begin with the profit model that is for developed by Facebook. So let us start. Okay, warning, run anyway. So if you just remember, we had our MAPE values, and let us paste the values of Dr. Chetna's values are also here, right? Yeah, Dr. Chetna for 98.2 had excellent MAPE 2.32, but it may be a case of overfitting also. Right. So see the same airline data set. Now we are computing for the profit library, which is for time series prediction. So this is the line that we use from profit import profit, right? Python library that contains the profit model. So now if you see with the previous code, there is hardly any difference. First line, I'm instead of auto Arima, I am importing the profit model. The rest of the things remain the same. As you know, Pandas, just for convenience, I have renamed the columns as DS and Y. So now we just keep on executing. Since the data set is same, the trend is there. You can see there is a trend in the graph. And again, we are training on 75% of the data, right? So 75-25 is the split. That is a training and testing. After splitting, so profit basically it's an object-oriented program, object-oriented library for time series prediction. So you have to initialize the model, right? Since the class name is profit, this is the constructor that you are calling and initializing to model. And the training data you are fitting to model. So the Facebook claims that they have highly optimized it as a multi-threading architecture. So even if you can see is the information that it takes is 2 threads. And it gives you information also disabling weekly seasonality, disabling daily seasonality. Right, so it auto detects here. So in this case, what we are doing, we are setting the forecast length and frequency. So the profit model. So if you see the model basically is a object of the class profit. And let us just read about the documentation for this. Make future data frames. So make future data frames takes periods, frequency and include history. So let me just copy the selection and show you each of the parameters what it does. So profit is available both for R and as well as Python. So make future data frame basically has make data frame with future dates for forecasting, right? So it makes future dates and it takes object M. M is the model object. So profit model object in this case is model, right? So basically we are passing the model. Second thing is periods. Number of periods to forecast forward data. So in this case, period, we are saying test of data length, right? So basically the test object. So we had in the test, we had, I think 36, right? 3 years data. So we are asking them to calculate for 36 and the frequency is M. M corresponds to month. So day, week, month, quarter, year. So we are giving the value of month because our data itself is a month-wise data. 5, 6, 7, 8, 9, 10, right? So the frequency is month-wise. And now we are asking it to print the future values. So now if you see the future values here, so from 0 to 143, I mean, this is just the displaying the 8-bit. See, this function will only give me the dates. Basically, if you see, the original data had only year and month, right? It did not have a date. So if this function, if you see, make future data frames, it says it makes future dates for forecasting. So just to be in order, it is having a date here, you see, 31. So basically now 1st of January 1949, 1st of February 1949 and so on. So it last value it takes as 30th of November this. See, since the original data set did not have a date, you can give any arbitrary date of the month. Now it is trying to do a forecasting. So in profit model, there are two more things that it provides you: y hat upper and y hat lower. So y hat is first of all the mean of the predicted value for the given passenger. Y hat upper and lower provides the estimate of upper bound and lower bound. I will explain you why is this a very important feature of profit. Right? So the FB model dot predict future. So this is the forecasting that it is doing. See, this is the dates that it is taking, right? Y hat, as already seen, it means it is a mean of the predicted value of the number of passenger, and a y hat upper and a y hat lower. This will be more clear in this graph when we plot, right? So see, this is the graph basically that is plotted. So y hat upper is the upper limit, y hat lower is the lower limit, and y hat is the mean of the predicted values. Right, so profit model actually gives you a possible range, right? This is not a fixed length. It is possible that your data may exceed, right? But this gives an estimated upper and a lower limit for the data based on the prediction model. Right, so you just execute this. So as I said, the models are easy to implement in Python, but it is a mathematics that takes a lot of time to understand. Plot the components obtained by the Python, this one. So if you see, the profit model automatically gave you the trend also that it observed in the data, right? Now if you see this trend line and if you see our original graph, right? So you can see that the trend is like this only. You can see a trend line going from here to here, right? So if you see, the profit model was able to extract the trend out of this data, right? And after removing the trend, you can, I mean, of course, you can remove the trend also, but this is the yearly data that it plotted, right? So we had a monthly data and it plotted the yearly data out of the monthly data. And now you can see that this is a nearly a stationary time series, not very close, but a near stationary time series. So these are the methods. There are various methods. You convert your monthly data into 6 monthly, 1 yearly. You try to convert it into a log data, right? So that the series becomes stationary. Now let us see what is the analysis of the results that we obtain. Right. So see, these are the actual passengers, upper bound, lower bound, and the mean of the predicted value. So if you see, the actual passengers are way different than what the Facebook model has predicted, right? And if you see, the MAE is very higher, right? MAE and MAP, we had a MAPE of 4% in simple Arima model, right? So this is how things go actually. So even if it is by Facebook, says one of the most advanced libraries and all, the error for our case was too high. So in this particular case, we may not adopt the usage of profit model. So always remember, in time series prediction, you need to apply different methods because different algorithms are suited for different kinds of data. Maybe the reason here is that because we had a trend in the data, the prediction was not so accurate. Maybe a stationary data would have been better predicted by the profit model. So this is all trial and errors and practice, right? So this was the profit model and everything about it. The last model will be on the deep learning, right? So deep learning obviously gives you a very good result, but it consumes a lot of memory, a lot of computational, a lot of GPU, right? So, and the biggest drawback is it provides you with a black box model. So black box model, because as you know, we have neural network diagram. Let me just check here, images. Right, so this is an example of a sample neural network. So what does a neural network basically do? It tries to find a relation between the input and the output layer. So by output layer means the thing that we are going to determine, in this case, the number of passengers. it makes a deep complex network and tries to assign weights. So let me see. Okay, this image, if you see, there is Wi, Wj, Wk. Right, so all the edges have a large amount, all the edges have their own weights. And the deep learning model will try to modify these weights so that a better prediction can be made. Right, and hence black box, and hence these models are known as black boxes. So the output will be a summation of input cells and the weights assigned with each of the cells. And there is no deterministic way to determine these weights. Each time you execute the algorithm, the weights may be different and the answers may differ a bit from the previous case. So although all the deep learning model have a very good amount of a very good result analysis. So in this case, I am taking a stock market data. So just to show you, this is also there in this data set. So the standard data set for a stock market, the date, open price, the high, the low, the closing price, and the adjusted close price, and the volume, right? So basically we are using Keras. I am more comfortable to use Keras than TensorFlow. Even if you are using TensorFlow, you are free to feel. And there is also a model called NBeats. It was a very recent paper for time series prediction. So I'm showing you the most recent paper also. This NBeats net basically takes care of seasonality and trend. And it also is useful for generic, like Profit is by Facebook. This was a very recent research paper that we were working upon. And we are implementing Keras also. So we input the sequential model. So for the dense layer and for optimizer, we are using Adam. So there are various optimizers. We are using Adams because that gives us the best result. So this code is available for NBeats, albeit a very long code if you can see. So right now we are only using it for our application purposes and we are not modifying the code at all. Right, and these are our standard NumPy and all these libraries. And let us import this data. Okay, and we are dropping the date column here. Axis equal to 1 is the column wise manipulation. So this is our data frame. Since we remove the date column here, this remains. And now let us plot the data set. Right, so this is the data set for, I think this is a closing price, right? So you can see here it is non-stationary, right? Because the mean is increasing here, and you can also see this is a trend component, right? So there is an increasing trend in the closing price towards the end of it. So usually by simple plotting, you can get an idea about this. So now there are two things. There is a normalized data function that we are writing. So normalize data, basically we can normalize using standard scaler also. Scaling is different actually. Normalizing is, in this case, we have using min-max scaler. So what does min-max scaler do is, it scales all the values between 0 and 1. So now why do you require to scale? What is the concept behind it? So the issue with ML and deep learning algorithm is that, so for example, if you have, let's say you have a height and the weight of a person, fine. So we can have height as 5.2 inch, let's say maybe 5.6, 6.1, 6.1, 4.9, 5.4, right? And let's say their corresponding weights in, let's say we take it in grams, just for an example, assume we are taking in grams. So let's say this was 62 kg, this would have been 6200 grams. Let's assume it 5800 grams, 7200 grams, 4600 grams, and 9100 grams. So now if you see, these are all possible values, right? 5.6, a 5 feet 6 inch person could weigh 58 kgs, which is very normal. But when you see it from a machine learning perspective, for a machine learning algo, these are very small numbers in comparison to these numbers, right? It has an order of difference, right? So if I divide this by this particular thing, right? So almost this number is bigger than this number by 1000 times on an average. Fine. So what will machine learning algorithms try is that it assigns more weightage or more priority to these values rather than these values, right? Just because they are smaller in numbers. Like, so for example, if we say 1 USD is 70 rupees, right, on an average. So if you see these both units are exactly the same, right? So basically it will treat an increase in 1 rupee, it will give a more weightage and correspondingly change 1 USD also, which should not be true, right? If this is getting increased by 1 rupee, it should have a factor of 1 by 70 here. So that is why when we normalize everything between 0 to 1 using min-max scalar, so basically all your series are in between 0 and 1. So the model will not try to give a higher priority to this column or column having higher values, right? So that is why we do normalization, and you can have standard scalar, min-max scalar. You can use anything which you want. This is just a function that we wrote, the load data. So again, you can see here. So first we normalize the data. So we send a data frame copy to normalize. So in normalize, open, high, low and close. So you can see here, open, high, low and close. We are transforming it to min-max scalar. So everything changes to 0 and 1. And this is the place where we actually try to split the model into training and testing. Just let me see. Oh, not here. Right, here we have taken the sequence length as 20 because in a month, if you see, there are 8 weekends and there is also a possibility of having a public holiday also. So we assume in a month there are 20 business transaction days on which the stock market is open, right? So hence we have taken the sequence length as 20 and then we divide the input into testing, training, exchange, white train, okay. So this is dividing into testing and training. And then let us see what is the shape that we get. First, we are showing the deep learning model. So deep learning is time steps. So time steps, basically here we are taking 19. I will tell you the reason. See, we took a sequence length of 920, right? Because we assume in a month we have 20 days of stock market open, and time steps we are taking 19 because based on the 19 days, we will try to predict the 20th day stock market closing price for a particular stock. Right, input dimension and output dimension are 4 because we are keeping open, high, low and close for our deep learning prediction. Right, so these are the number of layers that we add. This is something very common to deep learning experiments. So we are adding an LSTM layer, then again we are adding a LSTM layer. Activation function, we are using Irregular, which provides a very good result. And then we are using the optimizer Adam, and we are having mean squared error, MAPE, and mean absolute errors. These are the metrics the model will compute for us. A batch size is of 10. I will explain you what is this. Epochs is 100. So basically, let me just run this model. So epochs is like an iteration. So this model will run 100 times and try to improve itself. So you can see here, epoch 1 out of 100. It means like for I equal to 1, I equal to I equal to 0, I less than 100, I plus plus. So it will train 100 times. And you can see this loss value, right? This loss value usually reduces with each epoch, right? So with each epoch means, for example, so this was 0.0042. Now it became 1.610 raised to minus 4. So you can see the error and all. It may increase also. So for example, but overall, when you go for around 100 epochs, again, this epochs value is to be trial and error, right? You can have higher epochs and keep plotting this, right? So in epoch 1, what was the loss? Epoch 2, what was the loss? Epoch 3, what was the loss, right? MSC, MAP. You can just plot, like for example, epoch versus MSC you can plot. and then you will get an exponential graph, and then you can come across the value for which MSE was the lowest, right? So the model will take some time to run. So just see this particular figure, total parameters is 4,85,604, right? So if I tell you the parameters, for example, if you have a linear regression model, y is equal to mx plus c, right? M is a slope that you will get from the line of regression. So we have, and c is a constant. So a linear regression model will have two parameters, y and x, right? And just imagine how many parameters this deep learning model has. This has 485 and 604, right? So it's a hugely complex models, right? Let us see whether it executed or not. Okay, 41th epoch is going on. You also can try on your machine. So this was a shared graph from the previous image actually. We will load again. So as you see, the deep learning models perform exceptionally well, right? MAE is 0.01. It's like 1% error that you are getting for the prediction of stock market prices. Mean square error again is almost 2 to the power 10 raised to minus 4. Root mean square error again is very low. Right, so these models are amazing, but of course these are black boxes models. So you cannot get a definite equation or a linear line or a polynomial equation or a non-linear equation from it. It is just kind of a magic that happens inside.
So one question in chat box, what is exactly epoch?
Okay, what exactly is epoch? Epoch, as I said, epoch is, how do I say? For example, if I tell you, okay, do this experiment 10 times and report the results. So in that case, epochs is 10. Epochs can be taken as iterations, right? When you say a for loop is running 10 times, so I will say the for loop has 10 epochs. So maybe exact definition, because we directly use epochs. Okay, epochs in neural network. Okay, one epoch is when entire data set is passed forward and backward through the neural network only once. So I think we did saw the images of neural network architecture. So basically neural network learns by an iterative feedback mechanism also. Right, so once it is a highly connected layer, then we have a feed forward neural network. So the feedback goes back to the system. So this is what it is saying the definition. One epoch is when an entire data set is passed forward and backward. Right, so forward goes from this direction to the output layer, and the backward you have a feedback loop that comes, back to the system just to report what is the error and what is the loss that is computed. So eventually you will see the loss will get stabilized as you move across epochs. You can see 4.29 10 raised to 5, 4.31, so very near, 4.37, 4.51. So kind of the loss will stabilize to a particular extent. And I think okay. So model.compile also has a parameter for early stopping. Early stopping means that at times what happens, for example, even though we have given 100 epochs, it may happen that at 42nd epoch, from there on, your loss remains exactly the same value. That means the function has basically stabilized and there will be no more further improvement. So in that case, when we set the early stopping parameter, the model will not run for so long. For example, if you give 1000 epochs and on the 42nd you see, okay, for the next 20 iterations, the model is not improving. So what is the need of running till 1000 epochs? No use. So you can do a early stopping also. See, finally we boil down to 4.18 as the loss, right? And so, okay, so you will let us see mean squared error values also. MSC is mean squared 4.18, 4.32. Okay, validation loss reduced. Okay, let us see what is the prediction coming. See, it excellent it provided. So basically, the orange I think is the. Let me just see. Prediction and let me just show predicted and on the testing value let us see which is the orange one. So nearly it predicted everything very perfectly. So this is the min-max scalar that reduces the values, then that transforms the values between zeros and one for the same reason as I said key, so that the higher values, because if you see in this particular case, just check the volume number. In this SU case, this number is huge as compared to see this is 11,000, 11,000, 11,000, but this number is huge like 1, 2, 3, 4, 5, 6. Right, almost 1 billion. So that this does not become a dominant factor in the prediction, we do a min-max scalar. And now we have the n-beats model. As I say, again, the sequence length is 20. Eventually, we will be having a shape of 19. So that taking the 90th days input, we are predicting the 20th day. So again, n-beats takes these parameters. So it has also a hidden unit layer, just like the deep learning model. Right? And these are the standard. Like you can just refer to the algorithm of n-beats. See, now it is trying to study. Again, we are running it for 100 epochs. The good thing about n-beats is, for example, if you see the number of parameters here, even though we are having 100 epochs and 128 hidden units, the parameters are 214, 120, which are very, very less as compared to the deep learning when we had around 485, I remember. See, this was. Yeah, this was 485, 604. So more than double parameters are used in this. More than double means more computation time, more computational complexity. And let us see how the n-beats performs in the end. Okay, by the time it is executing, you can see because I had ran this experiment yesterday night. So you can basically see that you can see, okay, let us compare it side by side. And beats. And let us check for this. Right, so this is for LSTM. So now if you see, oh no, I think I made some mistake while copy pasting. And this is for LSTM. n-beats I need to wait. Okay, by the time it runs, I'm just comparing with the output that I got yesterday night. So you can see RMSE is nearly the same, 0.014 in LSTM and n-beats. MSE is 0.0002, nearly the same. And MAE improves by a very small amount. This is 0.011, this is 0.010. But if you see, n-beats performed nearly well as the famous LSTM, but had only half the number of parameters as you saw. It had 214, 2,14,000. On the other hand, the deep learning had 4,85,000 parameters, right? So a huge computational time saving we have obtained here. So, but I think it is taking more time to execute actually. I think this is min-max scalar ratio. So Rathod sir, I am almost done basically. I mean, this will just keep on executing, will take time. So I hope I could keep the time limit almost.
Yes.
So Kaggle, I would recommend everybody to solve Kaggle notebooks. You know, a huge amount of resources are there on Kaggle. First, try to blindly execute and then try to find the intuition. That is the way I tried to learn this. Right, because more time has to be devoted to exploratory data analytics. I had kept like T2, if you see, the T2 notebook is on exploratory data analytics. How do you deal with missing data and all those things? And any questions or any other thing that you wish to ask, you're free to do so, or you can drop me an email. That is also fine for me. I will just paste my email on the chat window. Chat. Chat.
There is a question from Dr. Chetna. Before final forecast value, again rescaling the value is done. Why?
Yeah, so the issue here is because what happens? So, for example, you had original values in this fashion. So, in the stock market, the original values were this, right? So, as a measure also, and just to evaluate the actual impact, because see, when you scale the values, there is a probability that the information may be lost, right? So what do you do? It's like, for example, all of this data will be converted to zeros and one. The model will be trained so that it does not become too much dependence on these higher values. And after the model is trained, what do? We try to get back these values, right? Because we don't want that the stock market price should be appearing like 0.001, right? We want some of these numbers to appear in our predicted model. Because when you do scaling, everything will be reduced to zeros and ones. So the prediction also will come in the values in the range of 0 to 1. But when you want to see a stock market prediction price, you actually want these prices to come. So after scaling, you do a undo of scaling, right? So these values converted to zeros and ones, model is trained, model is applied, and then we rescale the values so that we get these kind of values. So I hope Dr. Chetna that answers your query. Right. It's more like if I say you an example, let's say you are designing a house rate prediction. So let's say we want to buy a house and the rates may be like 50 lakh, 1 crore and something like that. You train a machine learning model, make a min-max scaler so that they reduce a 50 lakh house to let's say 0.5, and you train a model. So you don't want, okay, my house rate after 2 years maybe 0.75. You want a proper value of it, right? Maybe 75 lakh or 1 crore or something like that. And hence you do a rescaling again so that you get the original values in the scale in which you had provided the input values. Yeah.
So Mayank, done? Hello, Mayank. Sony madam. Hello. Yeah. Pallavi.
Oh, this is quite cool.
Hello.
Yeah, ma'am, go ahead.
So we have E momento also. Wow.
Yes.
Hello.
Yeah, ma'am, you're audible. Go ahead.
I think someone is speaking but not audible.
Yeah, Pallavi, madam. Pallavi, madam, but you go ahead.
Am I audible? Hello.
Yes.
Ah, yes. Now you're audible.
Sorry, what happened? Madam, now you are on mute. Pallavi, madam, you are on mute. Anyways, Mayank,
Yes.
thank you very much. Thanks a lot for accepting this invitation. And I'm sure you are always there for us.
Correct.
So in future, in future also, anytime data science, machine learning, AI related things are there, we'll give you a call. By the way, we will have a conference also, upcoming conference in June, an international conference, IEEE sponsored. It will be in June. So there will be a track related to AI, ML, data science. So we will give you an invite for that.
Yeah, sure. And it always feels great, I mean, 2005 to almost more than a decade हो गया SP से निकले. Wow. 11 years. So feels so good to
Yeah.
be back. And thanking
Yeah.
everybody and all the hosts and organizer. It was so smooth. I mean, rare ऐसा होता है कि invitation time पे आया and WebEx का link and everything worked so flawlessly. So thank you to the entire organizing team. And thanks to the audience who take out their time to listen. Thank you so much. And I really like the E momento, such में.
So I'll be sending you immediately the copy of that. Sure. So thanks, man. Thank you very much. Thanks a lot. And bye bye. Have a nice time. So participants, we will meet evening 5 o'clock. Again, Rocky sir will be there. It will be his last session. So join on time. Thanks. Thank you very much. So Mayank, have a nice time. Thanks.
Yeah.
Yeah. Okay. Thanks for that. Thanks.
Rathod sir, I think somebody is speaking and not able to
Pallavi,
hear. Some
actually,
mute is there, I think.
actually, Pallavi, madam, she was supposed to anchor and say thanks to you. So, but her, she is not audible.